What actually is a decimal? This number right here, 276.342, that's how most people would read that number, right? What does this number actually represent? What does this mean? So a common thing that I hear people say, just in like everyday life when talking about like numbers and fractions, decimals, people usually say they hate fractions but they love decimals. Um, so as a mathematician, that like kind of bothers me a little bit in a weird way. The reason being, the answer to the question, what is a decimal? The answer is a decimal is just a fraction. It's specifically a fraction out of a power of 10. Okay? So each digit here represents a place value. So I have my ones digit right here, right to the left of the decimal. And then moving left, I go up. So 10, tens place, hundreds place, thousands place. And then moving to the right, instead of repeatedly multiplying by 10, we repeatedly divide by 10. So we have our 1/10ths place, our 100ths place, and our 1,000ths place. It's hard to say. So this number right here, in the same way that just regular like base 10 numbers, like without the decimals, have an expanded form, we have an expanded form for decimals as well. So according to these place values, this number right here can be written in an expanded form of 2 times 100 plus 7 times 10, 6 times 1, 3 times a tenth plus 4 times 100 plus 2 1,000ths. And that's our expanded form right there. Okay? So all of these numbers right here, we can basically combine to we can find a common denominator and actually add those together. What would that common denominator be for all of these numbers? The common denominator would just be the biggest denominator here. It's really the least common multiple of all the denominators. So the least common multiple of these three denominators is going to be 1,000, because you can always just multiply by powers of 10 to get to 1,000. So just whatever this biggest place value is, or I guess you could say smallest, that's going to be your least common denominator. And then you could use that for these whole numbers as well. So you could write this as a fraction as 276,342 over 1,000. Now this is mildly helpful. It's probably a little bit more helpful to think of this as a mixed fraction, mixed number. So this is 276 and 342 thousandths. So this is actually a big emphasis in a lot of these textbooks that I see, that when you see a number like this, you don't actually want to read this as 276.342. It's better to read this, especially as a teacher, it's better to read this as 276 and 342 thousandths. Reason being, that language further emphasizes the fact that this decimal number is really representing a fraction. Okay, decimals are fractions, and that's kind of key. Okay, so how could you go about representing certain numbers as a decimal? So here's 43 fifths. So this is a fraction. How can we represent this number 43 fifths as a decimal? The way to do it is to represent this number as a fraction out of some power of 10 and go from there. Okay? So our denominator right now is 5. So if I want to make my denominator a power of 10, I could just find an equivalent fraction where the denominator is 10. And to do that, I could just multiply the numerator and denominator both by 2. So I get 86 for my numerator and 10 for my denominator. And so this is 8 and 6/10. So you could, normally people would write it like this, like write it like 8.6, but this number, you would read it as 8 and 6/10. Okay. This number right here, 12 over 2 squared times 5. What is this number as a decimal? So part of the key here is that anytime that you see 10, 10 is equal to 2 times 5. 100 is equal to 4 times 25, which is equal to 4 is 2 squared, 25 is 5 squared. In the same way, 1,000 is going to be 2 cubed times 5 cubed. So this right here is pretty close to being 100. It's just missing a factor of 5. So we need to multiply the numerator and denominator by 5, and then we'll get 2 squared times 5 squared in our denominator. So I'll get 60 out of 100. You could simplify this to just 6/10 or 0.6. All right? So 6/10 right here. That is our representation as a decimal. Let's do another one right here. So we have 11 over 8 times 5. That's supposed to be a multiplication symbol, not a decimal. Put a little x there. So this is the same as 11 over 2 cubed times 5. So this is pretty close to being 1,000 for our denominator, because we have 2 cubed times 5 cubed makes 1,000. And we're missing 2 powers of 5 over here. So let's multiply this by 5 squared over 5 squared. So we get 11 times 25 over 2 cubed times 5 cubed. So our denominator is 1,000. What's our numerator? 250 plus 25 is 275. So 275 thousandths is our representation of this number as a decimal. Okay. All right. What about the number 8/7? So this one is a little weirder because we don't have any 2s or 5s in here. Okay. So we'll explore this further in a later section, but part of the whole point of this is there's no 2s and 5s in here. There's no way to get to change this denominator to a denominator that is just a power of 10, right? So we can't just multiply the numerator and denominator by any number to get a power of 10. There's just always going to be this factor of 7 here. So our denominator always has to consist solely of powers of 2s and 5s in order for us to write it as what we call a terminating decimal, like something like just something like this, where the decimal stops after a while. This is called a terminating decimal. Whereas if you do like 0.1 repeating or 0.3 repeating, these are examples of non-terminating decimals, or like 0.12, 12, 12 repeating, something like that. Okay, so this would end up giving you a non-terminating decimal. We'll explore that more at a later time.